Hi, this is Rob Sin. This is for my linear algebra class. I'm going to do a couple of row reduction examples, and this time we'll actually talk about the solutions to those examples. Before I get started, let me make a quick note. You don't see any code down here because of this semicolon, so let me demonstrate that before we start. If I execute this, if I hit run with the semicolon there, it doesn't show the output. However, if I take the semicolon away, it does show output. So that's just a trick. Sometimes online, the labs I create, I put semicolons just to make things a little cleaner. You might have to take that off to get it to display. So here's what we've got. It's a little easier to see in this format, right, where I can see the rows and columns lined up. This is fine to enter a matrix all on one line, but obviously it's a lot easier to see it. So what are we going to do first? Well, first we are going to take row 3, and we're going to have row 3 equal itself plus something, right? And the something I want is twice row 2. So I'm going to do plus 2 times, row 1, 2 times row 1. And let's kind of talk about what just happened there, right? So this is the way I say row 3. Oh, wait, sorry. You missed a piece. I forgot a piece. What I had done, and it's already in there, is I had done this lowercase a equals capital A. And why do I do that? Well, the explanation is it's because I don't want to mess with this matrix. I don't want to start doing row operations like this because it'll destroy what's up here. And I don't want to do that. I want to make sure that as I go forward, I keep a clean copy of the original matrix so that if I make any mistakes down here, I can fix them. Okay, so that's why I was able to work with lowercase a. Let me ditch back out of that and go over what I was talking about. The key point here is that this just says row 3 of matrix A, right? Matrix little a. 3, why? Because in when I talk about, right, it's always row column, right? So the first thing inside the parentheses is which row I'm talking about. The second thing inside the parentheses is which column I'm talking about. So this says row 3, and then the semicolon, the colon says just do it and do it to every single entry in every single column. So, right, so the first part says, hey, we're down here in row 3, and then the colon says, hey, just do it to everything across there in order. And when I do this, it does the same thing. And when I do this, it does the same thing, except now it's pointed at row 1, but it will take the elements in a single column and match them up because of the colon. That's what the colon's there to do. Okay, so basically this says row 3 is equal to row 3, right? We're going to add a copy of row 3. We're going to add 2 times row 1, right? So I have plus 2 times row 1. That's what I'm doing. And this is a computer science equals where we're saying that the old R3, we're going to take that, add 2 times row 1 to it, and that's what the new R3 is going to be. So sometimes you'll see a left arrow there, and I'm sorry that my typing isn't very pretty, but that's what we're doing. This says take 2 times row 1, add it to row 3, and then we're going to make the new row 3 in A equal to that linear combination. So next we have our second pivot is here. It's the 3. And so we have to get zeros below it, right? Our first pivot was the 1. There are zeros below it. So we're on to starting with our second pivot and trying to get a 0 below it. So what do we need to do? Well, we need to work in row 3 again. So I'm going to say row 3, the new row 3 is equal to the old row 3. And now I want to do 2 times the first row, but I need to do a -2, right? I want to multiply -2 times +3 and get a -6 so that the -6 plus 6 cancel each other out, right? I want a -6 plus 6, and then I'll end up with a 0 here when I replace row 3 with this sum. So plus 2 times A1, A2, row 2. And by the way, let me just put that in, right? So when I hit execute, and notice that it goofs up, right? Of course it goofs up. I'm basically undoing what I just did. But this is the great thing about doing it this way. If I do make a mistake, everything's saved. I have the original matrix A, then little a becomes big A, and then it does this. This was fine. And then I realized that this is the line that screwed up. So I can just go back and fix this line and hit run again. And now it's working properly. Okay. But I want to make note of something. Okay, so this corresponds to an augmented matrix, right? So the augmentation bar would be right here. If I had this matrix in standard form, that's what it would look like. So let me get some room down here, and I want to show you some text. First of all, there are no solutions, and I hope you can see why already. But I'm going to think about what it would be like if it had this augmentation bar in here, right? And so, sorry, had this augmentation bar, right? So this first column goes with the variable x with a subscript 1, and this second column goes with a variable with subscript 2, x variable subscript 2, this one with a subscript 3, right? And we can figure out what these are equal to. So just to show you how it works in the LaTeX equations, the $ math equations in MATLAB, I'm going to pull this over here, and what I want to type is I want to type x with underscore 1 plus x underscore 2 equals 5. Just showing you how this works. This isn't corresponding to our problem yet. And you can see that I can type in this this math equation here. But let's see. So let's get this top row typed in. So it's 1, 11, and 9. So what we have, and move this over so we can see. So I have 1 times x1 plus 11x2 plus 9x sub 3 equals 4. Okay, so this is typing out, this is typing out what this top row means. And by the way, I'll show you something here. You get a little compressed with your workspace. So one thing you can do is you can undock. So this gives me a bigger workspace that I can see things a little better. And remember, you can always put semicolons after lines that you have right. You know that this stuff is right. So now I'm just working on the most recent copy of my matrix. And I've just typed in what's true about this top line, right? x1, 1x1, and this means 11 times the component x2, and 9 times the component x3 is equal to a 4. Okay. Well, that's great. And I could type in something for this equation too, but before I do, let's think about what this last section means. Right, the third row, right, let's insert that equation. Insert equation says that 0 times x3 equals 1. All right, and that's just impossible, right? We basically have shown that 0 equals 1. So what does that mean? Well, that means that if there are solutions, right, we're expecting to find the solutions to this augmented matrix, this linear system, by finding x sub 1, x sub 2, and x sub 3. Well, we've found that one of them is impossible, so that means that there are no solutions. And I'm not going to try to do any more than that, but no solutions. Okay, so I don't need to row reduce anymore, and you'll notice that you'll get one of these impossible rows. This third row is what you're looking for in RREF form that lets you know that there are no solutions. You get some kind of impossible equations where you have a row of zeros equal to something, which just is not possible. Remember, if these were switched, it still works just fine because I can have x sub 3 equal to 0, right? A component can be equal to 0. I just can't have 0 equal to something non-zero. So for our next example, we have this matrix B. And what we want to do is we need a pivot position. We need the top left position in my matrix to be a pivot. And if there's anything at all that's non-zero in this column, right, I have to start in the top left. Well, so I'm going to need to swap rows 1 and 2. All right, so again, working in little b, not capital B, so that if I make a mistake, I can fix it easily. And so I want to swap rows 1 and 2. So here I use these brackets. And so that's talking about what's happening to the rows. The colon, again, is just going to have the column indexes just come along for the ride. And what I want to do is I just want to swap rows 2 and 1. So I put them in, and I need the comma colon to have it just, do that all the way across the row. So let me kind of explain, right? So here I said, hey, rows 1 and 2, and here, this is the old matrix, it's swapping them, rows 2 and 1. Since they're in different orders, it's just going to swap these two rows. And again, it's just going to do it, the colon just means it's going to do it for every corresponding column entry all the way across that row. All right, so let me hit execute, let me hit run so you can see what happens. And exactly what we needed to has happened. We're just swapping these two rows. Okay, well, life is good, really good now, because we're actually in REF, row echelon form. Why? Well, look at my first pivot. I've got zeros below it. Second pivot is to the right of the first pivot, and it has zeros below it, right? These are not pivots. We're allowed to have non-zero entries, right, beside them. We just can't have any non-zero entries down here until we have a pivot. Okay, so we have 3 pivots, and we have 4 variables, right? This will be x sub 1, so x sub 1, x sub 2, x sub 3, and x sub 4. So we have 4 components to our vector, x sub 1, x sub 2, x sub 3, and x sub 4. And then we have these values on the other side of the augmentation bar that we're going to solve for. So first we're going to make the note that x sub 4 is equal to -2. That's interpreting the last line. So this process is called back substitution. So we go to RREF form. So we start in the top left and go to the bottom right, getting pivots and zeros below pivots. But when we get to the bottom here, it's quicker rather than doing row reducing all the way to RREF. We can stop here and do what we call back substitution, which means we start with the bottommost equation and solve it, which was pretty easy. And then we can substitute in 1 row higher and solve for that one. So that's what I'm doing. I'm doing a process called back substitution. Now this next equation is a little bit more interesting. So let me type it in. We have negative x sub 2 plus 5 x sub 3 minus 4 x sub 4. Now we know what this is equal to. We know what the x sub 4 is equal to. We can substitute that in a minute, and that is all equal to 6. So let me just hit this and make sure that I have it right. And everything looks good, but remember, I know that x sub 4 is actually equal to -2. So I can do that. I can put in the -2 there. And remember, you can do all of the formatting you'd like to. If you go back here, you can do centered equations so things look nice. All right, and so then we can solve, and I'm going to pause the video and solve it now. Okay, so I didn't make you watch while I sat here and I typed in. So I can say, I can use my text editing to, say that, hey, we already know that x sub 4 equals -2. So we're going to solve for x2 in row 2. So here you see x sub 4 going in, and then each of these is a new equation, and I'm almost done with what I wanted, so I thought I'd show you this where I come in and I can insert equation, right? But before I do that, if I double click on this, I can go get this code, right? And then I'm hitting Control Shift L, it's a Windows machine, so that's the hotkey. I believe it's Apple Shift L for Apple machines, and it brings in this original equation. Well, I don't want to have this original equation, what I want to do is I want to move the 5x sub 3 over to the other side, but I don't want to start typing from scratch because all the symbols I need are pretty much there. So that's just a quick, if I want to do something to this equation, I can come in here and copy its $ math symbols, right? So now I have solved for what I need. I know value for x sub 2. So I have a value for x sub 4. I have a value for x sub 3. Now in terms of the vocabulary that we need, the variables that correspond to pivots are called basic variables. So x sub 1 is a basic variable, x sub 2 is a basic variable, and x sub 4 is a basic variable. And then variables that correspond to non-pivot columns are called free variables because they can be anything, right? So that's why we have the x sub 3, which is a free variable, over on the right-hand side, because this expression can be equal to anything. This x sub 3 can be equal to anything, and then x sub 2 depends on it. Okay, so we're almost done. We need to solve this top equation in the same way. So I'm going to do the same thing. I'm going to add in some of this stuff to get an expression and pause the video while I do it. Okay, so I'm back and I've done a little bit of work here. So I'm setting up the top row equation, which is 2x1 plus 8x2 plus 6x3 plus 5x4 equals -8. And you can see here where I have solved. Let me scroll down and start the ink over. Okay. Right, so the first thing we have to do is we have to plug in for x sub 2, which we know, right? X sub 2 is here, right? And we are plugging in for x sub 4. So here's x sub 4 getting substituted in. Here's x sub 2 getting substituted in. This is just distributing the 8. And here that's multiplying the 5 times the -2. Now we're taking the 16 and the -10, which is 6, and subtracting to get it over to the other side, and then combining the 40 and the 6 x sub 3's into 46 x sub 3, and then notice that we end up with this when we move everything over. Now, you're not allowed to use this to solve for in your lab, right? You're supposed to show the by hand steps, but we can go to RREF form and notice that we're in RREF form, right? I get the exact same equation that's right here, right? If I were to set this up and simplify it, and same thing, I can see the 1x2 equals 2 plus 5x. It's right here. Let me get rid of that ink because it covers up the minus sign, right? And you can see that, yes, exactly the equation that we got when we back substituted is what we would have gotten if we had spent the time to go all the way to RREF form. So you can do either way. There's no particular preference. If you are allowed to use something like RREF and just jump right there, that's fine. But if you have to do the row reduction steps by hand, you get to pick which way you go. So we have one final thing that we need to do. We need to write x sub 1, x sub 2, and x sub 3 in parameterized form, or what you might think of as vector form. Okay, so let me show you what I mean by that. So if I have an equation, then what I'm going to do, let me pause this and get an equation up here, and then we'll talk about it. So let me show you, I just want to create a vector to get into this equation. And I need it to have 4 components. I need it to have x sub 1, x sub 2, x sub 3, and x sub 4. So I just created a vector, a real easy vector in MATLAB, and then I use this DSM script. So if you haven't seen the DSM script video, definitely check that out. It's a nice little function you can drop into your own MATLAB folder, and it will create the $ math we need for this equation editor steps. So let me jump back up here, and let's get a equation open, and then \vec will produce this symbol that you can see here, this nice vector expression. Now, textbooks a lot of times use bold when they use a lowercase letter that's bold, they're like, hey, that always means vector. Well, I like to type with the actual vector mark in there, then it's really clear what I mean. It actually looks like a vector. You don't have to learn 6 different ways to remember that something's a vector. It uses the right symbol, and that's right here. That's the \vec, and you can just leave a space. You'll also see people will type it with the curly brackets around it, and it does exactly the same thing. And the curly brackets work if you have several things that need to go inside there. All right, so now, but I don't want it equal to 1, 2, 3, 4. What I want is to say that it's equal to x sub 1. Right, so I just want this x underscore to go right in front of the 1, and right in front of the 2, and right in front of the 3, and right in front of the 4. And you can see that it's already, you can see in the preview that it's doing exactly what I want. Okay, so now I have a vector, right? And what it means to put this in parameterized form is to take these values up here and substitute them in to this. All right, so what I'm going to do is I'm going to actually copy paste from this equal sign over, and I'm going to add another vector. Okay, but now, so you'll see I have the same thing. I just copy pasted so I'd have this, but now I have an expression right here for what x sub 1 is equal to. So I can go into my LaTeX code and I can get what it's equal to. I'm hitting Control Copy, right? And I can go in here and I can find my x sub 1 in that second row and put it in. All right, so now I know that in my solution vector here that I need x sub 1 to be equal to -7 plus 23x sub 3. All right, now also I have an expression for x sub 2, so let me go grab it. This is my expression for x sub 2. I'm hitting Edit Copy. Now I jump in here, and where I see my x sub 2, I just substitute it, right, and hit OK. All right, so now we know what x sub 1 is equal to. We know what x sub 2 is equal to. What's x sub 3? Well, x sub 3 is a free variable, right? X sub 3 corresponds to a non-pivot column. So it can be whatever it wants. It varies freely. Okay, so we're just going to leave x sub 3 equal to x sub 3. And then what's x sub 4 equal to? Well, x sub 4 had an actual value. Remember, x sub 4 is just equal to -2. It doesn't matter what x sub 3 is. It doesn't depend on it. So for x sub 4, I can click in here, and for my x sub 4, I can just make that a -2. Okay, so this is one of the best ways to work with this equation editor to get something like this to create the vector for you, and then you can go in and make this. Now, I'm actually going to copy paste it again because it looks kind of nice, and I want to do another simplification step here. Oops, I hit paste too early, right? I need to hit Control-Shift-L, which gets me into the equation editor. And now I just have another copy of it right below. And by the way, you can also copy stuff like this and put extra copies in as you need. And you can, it's just like text, so you can select that text and hit delete. So why did I want to do this? Well, this is actually two vectors, right? There's the vector that just has the constants in it, right? The -7, the 2, and the -2. And this, in the third row, I have a 0. The constant is 0. So they're all basically linear equations with a y-intercept and a slope. And I'm going to separate them up. I'm going to separate them out. I'm going to put the constants in a vector to the left, and I'm going to put the things that are equal to that have the x3 in them, I'm going to put them on the right. So let's see how that goes. Right. So what I want to do is I actually want to create a vector. Let me do it this way. So I need a -7. Sorry, a -7, and then I need a 2, and these colons. So if I put a colon, that's a hard return. That's going to make a column vector, right? So if I were to just leave a space here, it would be a row vector. Let me show you that. So -2, 7, I need a 0, and then -2, sorry, that's a +2. Got it. And when I hit this, I get a row vector. The way I turn a row vector into a column vector is that I put the semicolons in right? And now I can hit the DSMX, right? I can jump right in here. Sorry, I thought I could jump right in there. All right. And I can just paste in this new matrix, okay? Boom. All right, so now what I've done is I've gathered the -7, the 2, and the 0 and the -2, but I still want to add this other vector, okay? So what I'm going to do is I'm going to get the -23 that I need, and I'm going to get the 5 that I need, and then I'll have a 1 from right here, right? The coefficient of the x3 is 1, so I'm putting a 1 right here, and then I have a 0. Why? Well, in the last row, we already discussed this, that there is not anything that has a coefficient of x sub 3 in the last row. Okay, so now that I've got that, I can hit Control Enter, and my DSM function has converted it so that I can jump in here, and I want to go plus this. All right. Now, each one of these things is actually multiplied by x sub 3, so I'm going to do x sub 3, and I'm edit copy, edit paste, edit paste. So this will put the x sub 3's in, and this is what I was trying to do. It took a little while on this screen, and you don't have to do this in your lab necessarily, but this is the work that you'll be doing by hand, is you'll be taking the form of this solution. I know what a value is for x sub 1. It looks like this. I just solved for it. X sub 2 the same way. And I know that when I plug all this in, I should get the solution. Okay, so then we break this up into two vectors where I have the constants, and then I'll have a vector for each one of the free variables. Okay, so I'm almost done. What we do to turn it into parameterization is we factor out that x sub 3. And so it just looks like this. I can go in here and I can take this whole thing equal to, right? And I can paste it on the end. Okay, and all I'm doing, that gets a little busy. Let me hit cancel on that. So I will jump back in, I'll edit copy it, and I'll put it down below, at least for the video, so you can see what's going on. Oops, I pasted too early again, so Control-Shift-L, then paste this in. Okay, so I have an exact copy of this, but now I want to factor out that x sub 3. So all I'm going to do in here is get that x sub 3 and that x sub 3, and now edit, cut that one, and I'm going to paste it right here. And you can see the preview, right? It's just going to paste that x sub 3 outside. So now that's what we mean by factoring it out. So if I have an x sub 3 times all of these, I can factor it out, and that just means to take the x sub 3 and multiply it by everything inside. In linear algebra terms, that's multiplying a vector times a scalar. But this is our parameter. The x sub 3 is our parameter. What is a parameter? It just tells, it's just things, the thing that can change, right? This is saying that a solution to this linear system is always going to look like this first vector, this constant vector, this static vector that doesn't change, plus this vector times the parameter. Okay, so there were infinitely many solutions to this linear system. So let's return to the top and actually take a look at this, right? So this linear system that we printed out here as an augmented matrix has infinitely many solutions. And if I want to know what those solutions look like, I can scroll down and see that right here. All right, that may seem like a lot, but let's try that one more time. So again, we're row reducing a augmented matrix that came from a linear system. So we have this augmentation bar here. And so we know that the first column is x sub 1, second column x sub 2, x sub 3. So we have 3 different variables and only 2 rows. So we're probably going to have infinitely many solutions. We'll see. It could have no solutions, and we'll talk about what that looks like later in the course. But what we first need to do is need to row reduce this. So let's not get too far ahead of ourselves. Let's do the C equals capital C, so I have a copy of the matrix. And then what do I want to do? Well, I've got to figure out what to multiply the 4 by to get 14, and the answer is 3.5, I believe, and they need to have opposite signs. So row 2 of matrix C needs to be row 2. We're going to take row 2 and add, we're going to do minus 3.5 times row 1. By the way, on your labs, feel free to use any letter you'd like. I just use different letters in the labs because in a document that I'm creating, it's easier if the matrices are all defined to be something different so that this C matrix doesn't overwrite something I've done with C up above or down below. So here we are. Let's see if this worked. And yes, it seems to have worked just fine. We're in REF form actually. We don't have to leave it quite like this because life will be a little bit simpler if we do a little more row reduction. For example, just to remind you how to multiply row 2 by a non-zero scalar, right? So I have, this is a half and this is a half. So if I multiply through by 2, then I'll have no fractions. And if I multiply through by a -2, I'll also get, I also just messed up. Hang on. This is, sorry. I'm struggle busing all of a sudden. And I just figured out what it was. This is an A here, not a C. For those of you who were laughing at me, it took me like 2 minutes to find that. Okay, so now I have an actual row reducing step on this one, and we've doubled up and switched the sign in the second row. All right, so that works. Now we're in RREF form. Sorry, so I want to come here, and Control E in Windows switches me from code to text. And so we know, first of all, that x sub 3 equals -1. Okay, and then we can solve in terms of, in row 1 we have -4 x sub 1 minus 2 x sub 2 minus 3 equals 3. Right, so we are just typing in what this means, and then for the x sub 3, we were adding, for this x sub 3, we were adding the fact that we know that it's already equal to -1. Okay. Let me get out of that. So here I'm going to use the equation editor here to simplify a little bit. I have to add 3 to both sides, right? So when I add the 3 over here, right, I end up with 6, so I can switch that to a 6. Okay, and now I can divide through by 2, so I can open this back up. I want to divide through by -2, so I have a 2 and a plus x, and then I end up with a -3. So just doing a little simplification there along the way. And now the last thing is that I want to solve for the pivots, the basic variables that correspond to the pivots. I want to solve for the basic variables in terms of the free variables. Well, the free variable corresponds to the non-pivot column, so the free variable is 2. So I would like to solve for x sub 1 in terms of x sub 2, which isn't that hard. Here I am just going to move the x sub 2 over to the other side of the equation and switch to a minus sign. And that's pretty good. And then I can divide through by 2. And just throwing in a division by 2 will work here. There are slightly nicer ways to do these fractions if you want. Here, let me kind of type out here so you can see it. So if I want this, it's frac, so the \frac with curly brackets for the numerator and denominator. So I could put a -3, I could put the 3/2 in with a minus in front of it and take this and replace it right here. So that's a little bit nicer way. Let me just show you. So I'm doing frac, and in the numerator, I put the curly brackets. I don't need a division bar because the curly brackets tell the equation editor what the fractions are. So here you go. That's another way to do it. You don't have to spend that kind of time if you don't want to. But now we have an expression for x sub 1 and x sub 3. So we know that our solutions have the form. And let me pause the equation editor here for just a sec. Pause the video while I work with the equation editor for a second. Okay, so I did this little trick again with the create a column vector x that has the subscripts I want, and then use this DSM script to get it turned into a vector. And then I came back up and put the x with the underscore in front of the 1, the 2, and the 3 to get the subscripts that I need. So I've gone ahead and finished up the algebra here in the equation editor. So you can see that our solutions are going to be vectors x that have the form where the components, right, x sub 1, x sub 2, x sub 3 have these values, right? Well, wait, I'm sorry. I got this plugged in the wrong place. So I'll go back to the equation editor and get my work right. So here we are. I believe this is right. So we took the x sub 1 and we substituted in the vector for x sub 1. The right-hand side up here goes into the vector. X sub 2 is a free variable. It can be anything. So it's just itself, whatever x sub 2 is. And then we did find out initially that x sub 3 is equal to negative 1. So we're taking the negative 3 halves, the 0, and the 0, I'm sorry, and the minus 1, which is going to go over here. And now I've just realized that I've messed this up as well. So let me fix it. So the minus 3 halves just goes in front of the 0 there. Okay, so now I have it right. And so now we have the proper form down here. This splits up into the two vectors that I'm showing here and here. Right, so the 3 halves, 0, and 1 are coming from these values right here. And then these in the second vector are the coefficients of x sub 2. So here we had a minus a half. I have those out of order too. Wow, this is screwed up. So let me switch it. That's the great thing about working in this equation editor. I can just, when I see a mistake, do you see this? I'm grabbing that middle entry plus the double backslashes tell it to do a hard return. That's between the rows. So I just paste it in right in front of the 1. And now I have it correct where the negative 1/2 coefficient is right here. This is a 1 because we're going to factor the parameter x sub 2 out. And remember, this negative 1 is a constant, so it's actually sitting over here. It's represented right here. There's nothing, there's 0 things multiplied by x sub 2 in the bottom row there. So this is the parameterized solution for the augmented matrix that we started with. Okay. Just one other thing I want to mention in here when these matrices get a little crazy with the denominators, and this one didn't. This is, whoops, sorry. This didn't, I've got myself confused. This matrix did not get really crazy. You can see the solution here, and it matches up in RREF form. It matches up very closely from here to up here. So you can see why going all the way to RREF makes life easy. You can see how to get these equations pretty easily there. Okay, but I do want to mention that let me just say D equals REF. And let me even divide it by something else. Let's divide it by, something prime. And now when you see this, you have these crazy denominators. And I showed this in another video, but if you didn't watch that one, there's a way to take a look at this, to create a preview matrix that will make everything in rational form. And it's called RATS. So I'm going to do RATS D here. And just to show you what the result is, this is a helpful one. Now, it hasn't changed the matrix. I can't do row operations like this. If you'll notice, it's a character array, but it does tell me what the denominators of all these fractions are. So, and it's a preview. It's a different thing. So it doesn't change. I can still go back in here and multiply the matrix D by something. So remember, this is a nice way to do a quick preview. Hey, show me what those denominators are. Remember RATS. So RATS for rationals. It's just going to turn everything that's in D into a rational number. And remember, it's a preview only. So it just gives me this character array preview of what the matrix would look like if it were all rationals, but the real numbers, these decimal approximations to the real numbers, are still there. That's what's in the matrix. Okay, so there you go. There is row reduction part 2, and going all the way to the parameterized form of the solution, the vector form of the solution. So get out there and do a bunch of homework and practice, because this is the whole course. Being able to row reduce and find these solutions is like 90% of an introductory linear algebra course. So go get to work on some homework and some practice. Good luck.